Welcome to today's webinar. The topic today is Grasshopper RFEM 6 presentation of the new example files. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the German and English webinars, website, newsletters, and so on. I will be the moderator today, and I will answer your questions together with Paul. The presenter of this webinar will be Lukas Sühnel. He's responsible for the product development of RFEM 6, and he's the main responsible person for the development of our interfaces. And he works also in the customer support. Paul Silvergien is also responsible for the interfaces between RFEM 6 and RSlab 9. And two other programs such as Rhino, Grasshopper, Tekla, Structures, Revit, and so on. And he will also answer your questions. I would like to show you how you can ask questions. At first, I switch off my camera that you can see the full screen. You can press that button with the question mark, then enter your question here. Press send and we will receive your question and we will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, then I hand over to Lukas. Lukas, it's your turn.
Thank you very much for the introduction, Andreas. Welcome also from my side. I would continue with the content of today's webinar. It's divided in two chapters. The first one is the new features of the Grasshopper interface. To be fair, we should have named it a preview of the upcoming features of the Grasshopper interface. We didn't manage to release them before the webinar as we planned it, but it will be released in the next days. In the second chapter of today's webinar, I'm going to present the new example files. So basically the goal is to show the Grasshopper link to those who haven't seen it before, structured into various chapters, the export of model data, load data, templates, and so on. For every topic, we created a sample file, and I would like to present them today. Let's start with the new features. The first new feature that we're going to release is the extension of the surface support component. We added here the options for non-linearities. The second new feature is a new component for the member type definable stiffness. So with that component, you can create via Grasshopper a member with your user-defined stiffness. The third component is a link to the surface load component. We extended it with the load distribution varying in Z direction. So in case you have to apply a hydrostatic pressure on a vessel, that would be the load you can use for, because you can insert varying forces in the global Z direction. We also created a new component for rigid links. All of those features were wishes from customers, so we try to cover them as good as possible. And the last feature, in my opinion, the biggest one and the one that I'm personally looking forward to, is an optimized plugin behavior when a new version of the plugin has been installed. This is relating to the fact that when you opened an old Grasshopper project with a newer plugin version, then it could happen that the connection wires were disconnected, at least for some components. That was caused by the fact that we constantly, extend current components, we create new components, and when we extend new existing component, then those wires have been disconnected, and this new optimized behavior should prevent that. You get an old tag, you get the previous component shown, you have a new component where you can run an update of the components, and still the wires should remain intact. So that's a good feature for such cases. All right, now this will all come in the next days. Now let's hop into these sample files. Let me introduce them briefly. We will, as I said, we offer those sample files as download on the webinar page. So yeah, you can download them and use them for yourself. Just a quick overview. I have 6 files here, 6 Grasshopper files. It's about the export of model data, export of loading, using templates and design add-ons. Mesh analysis and results is a chapter. Import into Grasshopper and modifying an active RFEM structure with the Grasshopper component with our Grasshopper plugin. These are the 6 chapters. I will introduce each of those sample files in the next 45 minutes. And in combination with these sample files, you may need to use an RFEM 6 file or a template that we also provide in the download link. Okay, I will open a Rhino and Grasshopper and start with the first file. So yeah, this is how these sample files look like. As I said, I'm going to start with the export of model data to RFEM. Maybe before we dig into that, a brief introduction of the plugin itself for those who haven't seen it before. You can download our plugin via the Rhino Package Manager. And after the installation, you get a new tab here, Dlubal tab. And this one is divided into 3 chapters: the model data components, load data components, and general components. I will focus now on the center group here in this example, and start a little bit with the explanation how our components are set up, and then also with an example so you can check it, modify it, and so on. Regarding the introduction of our components, I left some comments in here. In general, our components work similar to other components that you know from Grasshopper. We have inputs, we have outputs, usually just one, depending how you use them. And it depends a bit on your use case, what inputs you have to fill. I can't say you always have to use this and that input. It depends. If you plan to export a tapered member from Grasshopper to RFEM, then you need the Grasshopper line, the section distribution input, section start, and section end, for example. If you plan to export a rigid member, the member type rigid from Grasshopper to RFEM, then you only need the member type input. So we can't say this is mandatory, this is optional. Here my tip is check the RFEM graphical user interface, what is requested there from you, from the user, and then fill the same inputs in Grasshopper. We try to give you additional help via the tooltip. So whenever you hover with your mouse over an input, you get an additional information. Those tooltips contain information about the expected input, supported types, expected units. For example, for the member type, you could argue what is a member type, what's the proper input for that, a string, a value, and then you can see here value list in the tooltip. So you can call up a value list, very often used feature for our interface, for our plugin components. It will give you the list of options, and then you can simply select the one that you need. For the rotation angle, for example, you get an information about the unit. So also check the tooltips as a quick help if you are not sure how to deal with certain input. We have also an expand and shrink option in our component. Here we have to say thank you to Bollinger Kroman, Diego Apelanes. They provided us with this code. It it's really appreciated and a nice feature because it reduces the place of the components if you only need some of the inputs. And yeah, it's simply a nice feature. Concerning the general setup of our of an export of a script, yeah, that has the target to export data, you would create multiple components. I have here one for members. You would need additional components probably for sections, for materials, maybe for nodal supports. You fill them with the information, and all of those components then have to be collected inside the RFEM export component. Yeah, that's this one here. All of the components are connected to the input, and then you can run the export by a Boolean toggle, a button, or similar options, yeah, which you connect to the run import. My suggestion is using Boolean toggle. It has two pros. Basically, if you keep it true when you connect it, then you have kind of a live link. Yeah. So whenever you change something, the export will be triggered again and you get the result in RFEM directly. And the other big pro is that when you made an error in the input somewhere in your script, and you leave it on true, you get here usually a red or an orange bubble, as you can see here. And this one contains an error message. If you use the button, this error message will disappear in a millisecond after it showed up. So that's why I prefer Boolean toggle. Yeah, so far regarding a quick introduction of the components. Now we can take a look at this little example down here. Let me show what I did. I have here a group which represents native Grasshopper components. So that is all components which are basic in the Grasshopper program. I create just a little structure here, a couple of columns, a slab with an opening, and I collect all of these objects here in these surface, curve, and node or point components. Yeah, and I will use these lines, surfaces, or these objects later on in my Dlubal components. And how I do that, I will also show now in a second. Basically, if you take again a look at the member component, I think it makes sense to use the lines that we just created via Grasshopper in our member component, yeah, as the analytical line, as basically start node, end node. So what I'm doing here is I connect simply this curve component with the member component in our with our member component, yeah, with the Grasshopper line input. Then you have additional inputs to assign the required and necessary information. What section do you want to assign onto that line? Maybe you want to assign additional comments or even eccentricities. That can then be done via direct inputs or additional components. I also create here a material and a couple of sections in this little example. Here we often get the question, will you provide a library for the materials and for the sections as a component? And we actually decided against that. The library in RFEM contains hundreds or thousands of materials and sections. So we don't see the point of having such a component in Grasshopper. It is quite easy to create your own little library. I'm using here a value list in that little example. You can edit the value list. You just fill in let me use this one here, that's better. You fill in like the short name that you want to see when you open the drop down, and then the full name that is expected by RFEM. The full name usually contains also the standard. So if you document it in that way, you have a nice little library where you can choose, let's say, those materials that you frequently use. Yeah. Okay. Yeah. Small tips like that are mentioned in these sample files. An important information is also shown here. In my webinars that I do about the Grasshopper interface, I usually connect my components directly, material into the section component, because in a section I expect, or the material index number is a required input. So it is just logical to connect them. This connection, however, only works if you assign the index number to the material, because actually here the input expects a value 1, 2, 3, 4, 5. So the index number of the material, and this information can only be shared if it is assigned beforehand. That's important. Keep an eye on the index numbers of the components. It is not that difficult, even if you think about members or something like that, where you have maybe hundreds or thousands of index numbers. You could use a series component, which you link to another series component for additional members to count basically the lines that you have collected in here and assign numbers to that. That's quite easy. That example also creates a couple of nodal supports, thicknesses and surfaces, with additional information how you can trigger a fixed support, for example. And at the end of the example, we have the export. And here highlighted in red, the button that you have to press to start this whole example. As I said, a Boolean toggle. And this is what I want to show here as well. So let me quickly run the export from that little file to RFEM. I double click on it, and now the programs will communicate with each other. And in a second, I should see the result. Okay, here we are. I stop the export again. I set it back to false. With that, I make sure that whenever I change something, it will not automatically trigger the export again. As you saw, it takes a couple of seconds, and you might want to modify more things before you run the export. So that's why I set it back to false. You can leave it on. That is up to you. And as as you can see, the result is clearly visible. We have the same little structure. I have here eccentricities assigned on these members. As I showed before, materials, cross-section, everything has been exported correctly. The nodal supports. So that is the first little example that I wanted to show here, the export of model data from Grasshopper to RFEM. All right. Then let's have a look at the second little sample file, which is about the loading. I could have done it in one, but it is, I feel, if you begin with the interface, a little bit of complex, like maybe too much information on one file. Therefore, I split it up in 2 sample files. So that's the one for the loading. I will increase the size again a bit. And maybe as a quick introduction, what we cover here in our loading chapter, you can create load cases via the Grasshopper interface. After the load cases, you can also create load combinations and design situations. Design situation, ultimate limit state, serviceability limit state, those types which are required as an input in the load combination. And then you can export these load combinations. Additionally, this sample file covers a couple of loads. Obviously, you want to create loads inside your load cases also in Grasshopper. I mean, probably up to you. And here we cover nodal loads, surface loads, member loads, line loads. There are more options here. I just use 3 of them in this little file. And on the bottom, also a topic which should not be dismissed, imperfection cases and imperfections. Initial sway on columns, pre-camber. Depending how you plan to run the stability analysis in RFEM 6, this might be necessary, and you can create it via this plugin. So let's have a brief look at the sample file as well. Actually, this second sample file is an extension of the first one. As I said, I wanted to focus only on the load related data or info objects. Yeah, that's what I wanted to focus on. The rest is still part of this script. It's however hidden in that cluster file. So if you double click on that button or on that icon, you see that behind that cluster, we have basically the content of the first sample file. Yeah. All right. Yeah, regarding the load cases, I think it's clear that we can create them via Grasshopper. Necessary information, important information is the static analysis setting. Should it be analyzed according to first order, second order, and so on? That's an additional component. It is shown here how you can treat it and handle it. Another important input for load cases is the action category. Basically, is it a permanent load case? Is it a live load? In case a live load, according to Eurocode, is it a group A, B, C, D, E live load case? Yeah, there are different options that you can select via this classification component. It's like a little library, because the expected input for the action category is a, let's say, relatively complex string text. Yeah, you can see it here in the tooltip, action category permanent G. That is nothing which you know directly. Yeah, you don't know how to import that. That's why we create these strings via this component. Yeah, this is how I set up load cases. I fill these load cases with loads, as I showed before. Here, maybe as a comment, any value that you have to input into our components usually is related to the SI units. So meters, Newton, yeah, as a simple example, yeah, most common stuff. You cannot change these units into anything else. So this transformation can be done via a little recalculation if it's required. Yeah, you can easily use a multiplication component, assign the proper factor to convert a pound force into, I don't know, kilonewton related unit, yeah, or SI related unit. So that can be done in Grasshopper. And here, as an information, we always expect the SI units. I documented it again in the tooltip, as you can see here, Newton, or for moments, Newton meter, for example. That's also why I'm using here high values, yeah, 2000 Newton for 2 kilonewton. Also obvious, I hope at least it is obvious if you deal with the components, the load components, we use a lot of value lists here to define, yeah, the proper load. Yeah, there are various ways how to create a load, and most of these inputs can be defined via value lists. All right, so far regarding the loads. The load combinations can be built manually via our plugin. This component is basically divided into subcomponents. We have the general load combination component. Here you can assign the static analysis setting, you can assign a name, you can assign the numbering, more settings as well. The actual combination will be done in a second component, load combination items component, it's called. Here you combine the load case index number, so load case 1, load case 2, 3, depending which numbers you assigned to your load cases. That you combine with the factor, 1.35, 1.5, 0.9, whatever is needed. And this combination then can be done via little lists. So the first load combination that usually comes into mind is, the dead loads multiplied by a factor. And that's basically load case number 1 multiplied based on the Eurocode, let's say, with the factor 1.35. Next combination is dead loads plus live loads. Dead load case number, live load case index number, 1.35, 1.5. So that's how you can set up multiple load combinations via Grasshopper. Yeah, and if you have all that, you can connect it again to our export component. Yeah, same logic. Here I used a little data component in front simply because, yeah, to connect these components, sometimes you have to zoom out, at least as far as I know, and then draw these lines from here to here. So what I do is I have this little data component, which I move to the place where I need to have it, and then have an easier connection. That's all about it. Yeah, it's not required to do this that way. Yeah, let me also show that export. Yeah. Again, we run the export by double clicking on the Boolean toggle. Wait a second. All right, export is done. Let's have a look. Same structure. Yeah, that was all part of this cluster file. New is the load cases, the design situation, the load combination. This all has been created via Grasshopper. Also the imperfections, as we see here, or the loads, node load, surface load, and also wind load as an example. Yeah. All right. So far regarding the second sample file. Now let's have a look at the third one. The third one is about using templates and how to decide, how to control the design add-ons. So first sample file, how you can export model data. Second sample file, how to export loadings. Yeah, that I think it's quite clear what we can do in general. Yeah, what features we cover here. Now, templates is a complete additional topic, I would say. It's really a strong feature which you may or may not know from RFEM 6 or previous versions. Let me show it maybe in advance. Think of following example. If you analyze or design the same kind of structure again and again. So maybe you have the same kind of load combinations, yeah, or you play, or your protocol always looks the same, yeah, the same graphics are included and so on. Then you don't have to do it every time from scratch. You could use a so-called template. You create such a file once, so you would create a new RFEM file where you define all these settings and properties that you want to save in such a template file. Then you save it as a template, and whenever you create a new file afterwards, yeah, then you can refer to that template. So basically you create an empty file in which the information from that template file will be imported. And let me show that as well. And as a result, your file is not empty anymore. Yeah, you get these load combinations, the protocols, maybe even materials and cross sections, whatever comes to your mind, what you want to have as a default in a new file can be saved in a template, and that will be imported afterwards. Takes a moment. All right. Yeah, so in general, an empty file, yeah, no materials and so on. But if you check, for example, the load cases, the action categories, the design situation, load combinations, all those things have been saved in the template and are now already available. I don't have to create that manually anymore. Same for the protocol. Yeah, there's already a predefined protocol inside. Little spoiler, it contains graphics as well. So yeah, that is a feature that we can use manually in the RFEM graphical user interface. And we have also access to that via Grasshopper. You can, I mean, creating such a template is a manual work in RFEM, but once you saved it, you can also use it in Grasshopper. You basically just link to our export component the path to that template in the use template input. That's all you have to do. Then the template will be preloaded into the file that you create with your normal export. And one thing that is quite important for that workflow, you should not overwrite, or you should not use overwrite during the export. Yeah, that would overwrite the data that we import with the template. That is basically nonsense in that moment. So therefore, make sure to set it to false. And then you can use basically those types, the information that you have in the template, in your Grasshopper code. And how can you use that? Well, let's go back to the example with the load cases and combinations. Let's say you don't want to create these load combinations manually in Grasshopper, as I showed it before. This whole chapter is missing here in that example. Yeah, I have here some model data and I have here some loads. But the load cases and combinations, this has been skipped. It's part of this template file. And if I create now a new load, a node load, a member load, whatsoever, I need as an input the load case index number. Load case 1, 2, 3, 4. So all you have to do is assign the index number of the load case this load should be placed into. Obviously, this requires the knowledge of, what load case is what index number, but I mean, that is okay, I guess. Where else could it help to use templates? They can also help you to access features that you can control via the Grasshopper plugin. For example, currently our member eccentricity component allows only to generate eccentricities with absolute values. Yeah. In RFEM itself, not sure, I can quickly open a file, just a second. We have additional options. Yeah, we can define eccentricities relative. We could say the eccentricity should always be basically the distance between the center of gravity and the top flange or something like that. Let me show that in a second. Okay, if we think about member eccentricities, then instead of just the absolute values, I have additional options in RFEM. I could, for example, say, please create an eccentricity which is relative. So depending on the cross-section size, it will always take half the height as an eccentricity, basically. And what I can do is I can save these eccentricity types inside my template and then use them in Grasshopper. Yeah. So instead of creating the eccentricity manually here and assigning them to the member component, I could again just assign the index number 2, which is the relative eccentricity, to my member component. Yeah, so the templates also allow me to use features that are not covered by our current plugin. Just another example, you could skip the whole generation of materials and cross sections. Yeah, you can save them in a template and just assign the index number into the section inputs of the member, for example. And the last feature that I want to mention is the control of the design properties. Let me show that maybe again in RFEM. Yeah, let's imagine we want to run the steel design in RFEM afterwards. For the steel design, we have to define additional properties. What's the buckling length of the column? That's a property inside the member dialog, design types. Here I can say use or perform flexural buckling, lateral torsional buckling, and so on, all these checks. And then use as a buckling length, maybe length XYZ, 5 meter. Yeah. These inputs are, let's say, relatively complex for a Grasshopper component. And as a quick solution, until we have them as a component itself, we thought of following. You could create these types also in advance in RFEM. Yeah, you could create an effective length type for a single span beam. Yeah, support at the start and at the end, which is probably covering 70% of the cases. Then you could create a couple of additional types, maybe one where you have an internal support in Y direction, intermediate support in Y direction, maybe with 2, 3, 4 intermediate supports. So you could create multiple types, save them in the template, and then use them as input in Grasshopper. Yeah, same logic. In my template that I have used here, which is also provided in the download folder, I have multiple types. I have steel effective length type 1, which is a single span beam, I think, and steel ultimate limit state configuration. In both cases, for those members, I want to use type number 1. Here I switched it up. I used the second ultimate limit state for configuration in this second group of members. So that is how you can assign already design related information inside Grasshopper. And then you save again time in RFEM. Yeah, that's the purpose of that. Yeah, that is, in my opinion, what speaks for using templates. Additionally, this part with the protocol, which you can also save inside the template. So you can skip the generation of that manually in RFEM. It can already be imported via the template. And now let me show what I did here. So I will close again the RFEM file that I have. Put it to the right hand side, run the export. And I'm basically creating the same file that I had before in sample file 2. I just skipped the whole load combination part and load cases part. Yeah, that is part of the template. And yeah, I also have a protocol included in here. Let's wait for the result. It's a bit slower due to this webinar software. All right, now it should be finished. Okay, so we see again, same structure. This time, however, with, let's say, more load combinations, the ones that I saved in the template file. And then again, I was able to use these load cases for my loads. I assigned all of these information anyhow in Grasshopper. Additionally, I have assigned steel design related information onto my members. So first of all, inside the template, I was able to save also which add-ons should be activated. Yeah, we also have no control about that in Grasshopper currently. There's no component where I can say, please activate steel design. This is an information that has been saved in the template, as well as the information what code should be used, what national annex. Yeah. And then additionally, as I said before, I created a couple of effective length types. I used only the first one, I think. Probably on those members. Yeah, single span beam type has been assigned directly via the plugin, and also design configurations, which we can find down here. Yeah, I created multiple in my template, and I'm using plastic and stability analysis, elastic and stability analysis, so various types that I assigned via Grasshopper. And then I can run the analysis. Let's quickly do that. There was also an option while it's calculating. There are two options: calculate locally and calculate in cloud. And that's a new feature, kind of a new feature. So when you have big files which require a lot of power, then an alternative way could be to send the calculation file into the cloud. There are different PCs with different amount of cores that you could use. And then it will give you an information when the calculation finished. So you can download the file with results again. And yeah, in the meantime, you can work on something else, yeah, while it's calculated in the cloud. If you do it locally, your PC might be very slow due to the multi-core use of the calculation. So yeah, just as a side information here while we were waiting for the results. Okay, so files calculated. What I wanted to show is that since we were able to design all these information in Grasshopper already, I have now also results for my steel design ready here. And all I had to do is run the calculation in RFEM after the export. And yeah, and I have my results ready here, as well as the protocol, which I also mentioned a couple of times now that I saved it in the template. I can open that, and it should contain at least graphics about, what did I print? Node numbering, member numbering, an overview graphic of the cross sections, load case related graphics. Is it on the other screen? Right. Yeah, there it is. Yeah, usually it's much faster. Yeah, so here, these are all graphics, for examples, that I included in the template, and I have them already here without a manual modification. Yeah. Load case related graphics, and even one for the design result. So templates in general, for RFEM could be a big help, about, designing the same kind of structures again and again, or in the daily work in general. And it's also a big big benefit for the Grasshopper interface as well. Okay. So far regarding that. Let me go to the next sample file, number 4, which is about, anything, as I said, that comes after the usual export. You create model data with Grasshopper or RFEM, then you create load cases, the combinations, you define the loading, and the next step usually is to deal with the mesh, mesh settings, and then you run the calculation, then you somehow deal with results, and this will be covered in here. Different groups here. Again, it is built up on the previous example. You can see here that that's the code for the model data, for the load data, and so on. I wanted to set the focus on these additional topics. So the first one is about the mesh settings. We have here, for example, a component for the global mesh settings. What should be the target length of the finite element in general, and so on. And then we have additional components here represented by the line mesh refinement to refine the mesh on specific objects, for example, on certain lines. But we could do that also we could also assign a nodal mesh refinement or a surface mesh refinement. So various options how you can manipulate the mesh via Grasshopper. And then the next step would be obviously to calculate that structure. Again, all these components should be connected with the export. And then you can run the export to RFEM and you have a proper mesh, which is nice. But before we do that, I want to cover also the next steps. Instead of running the calculation manually, as I showed it before, you can trigger the calculation also via a calculate component. Here you can decide if you want to analyze only specific cases, just specific load cases or combinations, or if you leave that input empty, then calculate all as a function is triggered in RFEM. After the calculation, or no, how does it work? That's maybe worth mentioning. It is kind of like a stepwise export. We start with the regular export of the model data, load data, and mesh information. Whenever this export is ready, it will give us a Boolean parameter, a true. It will output here true, and with this true information, I can run the calculate component. And when the calculation is finished, I get again a true output here, and with this I start the export of the results. Yeah, that's another component part of this right chapter here. Here I can export my results into CSV or XML files. Yeah, that's the option here. And you only have to specify the location of the folder you want to have the results in. When the export is finished, you can read the content of these files. This is, however, pure Grasshopper components, so this is not specific to RFEM. That's a read file component. Wait, here, read file component from Grasshopper, and this then just some data handling to get maybe one specific value out of that whole file. Yeah, that's possible. And to show it, I quickly want to remove the existing results, which I forgot to do. Yeah, because that should be empty here now. It will be like that in a second. Just let me delete the folder. So if I run it again, wait, why is it? Public results. Oh yeah, sorry. Public results. Now it should be empty in a second. Yeah. Okay, I just deleted the existing results, which yeah. And now you can see that, of course, this script is failing. There is no such file. And I want to show the process now live. Therefore, again, I will run the export first. And this is now a stepwise export. Yeah, it will basically, you can see that on the bottom of RFEM. It will run the export of the model data, load data, and so on. Then it will make a little pause. Yeah, now it's running. Then there's like a pause. Then after that pause, it's starting to run the calculation. You can see that mesh generation and calculation in a second, without the dialog, by the way. Yeah, you don't get the diagram if you start the calculation externally. And then again, a pause to export the results. Yeah, that's how it's done currently. And currently, we also export all result tables that can also be controlled inside a template. You can select which result tables should be generated, so you don't have to deal with all the result tables always. So now the export is done. I can cancel this export, this whole process. And what I have to do is, because this is the English webinar today, my tables are named slightly differently. So I will change the name of that pass here. So I can show it even. So these are the CSV files that we now received after the export, and I can use, for example, copy. I can use this one, replace it here. Oh, that's working correctly. Yeah, looks good. And then I have here the results, the global deformation on nodes as a result table in Grasshopper. And with a bit of filtering, I get the maximum nodal deformation. Yeah. That is the fourth sample file. You could think about additional features now. You might say, okay, hey, if I have a result in Grasshopper, I could maybe use additional plugins like Galapagos to run calculation loops. I showed that in a different webinar briefly as well, only, but that is also possible. Yeah, you could say this is the target value which you want to optimize. You want to reduce the deformation, and as a manipulation, it should manipulate the height of the structure, the length, whatever. And then it could run automatic calculation loops. Yeah, just as an idea. Okay, so far regarding the fourth example. Let me close everything again. And then we turn the way a bit around. Now I open a file in RFEM 6 in advance, and I will open also the 5th sample file. And this one is about importing data from RFEM into Grasshopper. So the other direction basically is also possible. Yeah. Instead of the export component, you have also an import component. And with the import component, you can read information from RFEM into Grasshopper. Let me double check. Yeah, still waiting for the file to be opened. Okay. So let me put that on the right-hand side. It's the file that we created before. Yeah. That on the left-hand side. And yeah, basically we can import, or we can run the import again via a Boolean toggle. And here it's basically required to use a Boolean toggle because it has to stay active. Yeah. Okay. So I imported my data and I get a RFEM data package. That doesn't help me at all in the beginning. So I split that global data package up into object-specific packages. Yeah, that's this RFEM data component. And I still have unreadable data packages, so-called GU objects or containers. And I can read the information from the section package via my section component. And this is the same component that we used for creating a section. Yeah, that's the component for creating a section, and I can switch it around from assemble to extract, and then that's the same component. So it basically mirrors the inputs and the outputs. Yeah, and then you get the results that you expect, the names of the sections, maybe here the area of the sections in square meter, yeah, SI units always. For nodes and lines, you get also real Grasshopper nodes, real Grasshopper lines, and also surfaces. So what you can see now in the viewer of Rhino, I basically imported the analytical lines and surfaces from RFEM into Rhino or Grasshopper. Yeah. You can bake them and use them somehow if you want, for example. Yeah, and yeah, so far regarding that. We can modify the import a bit because now I imported everything in big files. That is maybe a bit like performance-wise questionable if you want to import everything. Depends what you plan to do with that. You can also import only specific objects. You can use Boolean toggles to tell the import component, import only nodes and lines and skip the rest. Yeah. So then the import is much quicker because it only has to read a couple of information, not all of them. So that you could use. So as soon you assign a true command to any of those inputs, it will only import that, and the rest will be set to false. If you leave it empty, if you don't assign anything to these components, everything will be imported. That's the logic here. And then again, we split the information up. Let me quickly show that. And yeah, we see we imported the nodes again, the lines again. I skipped the surfaces this time. And we can also see that other information won't be shown, yeah, sections, because I simply did not import them. Yeah. All right. Then we have also filter options. I can use them before the import or after the import. These are the next two examples in that sample file. I have here a filter component, and with that filter component, I can specify more detailed what object I want to import. Again, I want to import only nodes, but not all of them. I'm just interested in the nodes of the frame on the negative y direction side for some reason. Yeah, I only want to import those for nodes. So I use my filter here. I can again switch between certain types, and I can say, please import the nodes with the y coordinate between -9 and -11. And if I do so, I should get only 4 nodes after the import. that's the case. And as I said before, I can also use the filters afterwards. So let me run the import here as well. Same example, I import all the nodes. Now really all nodes, but then I want to split up the data package for my nodes. I want to maybe for some reason I have a couple of branches here. Yeah, I need these 4 nodes again, same ones that I used here from -9 to -11 for something else, maybe to create a surface or whatsoever. And then you could use other nodes, yeah, again with the filter component to do something else. Yeah, so with those filters you can sort the imported data afterwards, and if you place the filter in front with the filter definition, then you can control the amount of imported data. So that is the import from RFEM into Grasshopper. When would you need that? Well, an example or an idea, a checking engineer explained me in a call. He said he thinks about using Grasshopper as a converting tool. Yeah, checking engineers, they deal with different structural programs. They have the task to design the same structure in a different structural analysis program and to convert the data. His idea was to create a tool in Grasshopper. Usually all programs have Grasshopper plugins. So just an image, just an example, he's getting the structure analysis from the structure engineer in Dlubal. Then he imports the information from RFEM or from Dlubal into Grasshopper, and then he extracts all the necessary information and then connects them again to, I don't know, maybe the Sophistic or the Skia plugin to generate the Sophistic or Skia model based on the RFEM model. Yeah, that is an idea. You may have others as well. We offer just a feature here, and we are interested to see what our customers do with it. Yeah. Okay. Example 5, and now the last example, and then we are already done for today. Oh, actually, I can leave the file open. The last example is about the modification of an active RFEM 6 file. Yeah, imagine you have a structure. You created a structure in RFEM, and for some reason you want to modify certain parts of it. Maybe parametrically, yeah, that's why you use Grasshopper. That can be done, and I have here again a little sample file that is covering 2 tasks. Let's say the first task should be to, for example, modify these 2 members, member number 5 and member number 7. We want to assign here hinges at the ends, yeah, because they're connected to the web of the column. Then we can do that. And the second task will be to move the opening. So let me show how that can be done. Basically, we have to create, or we have to use a member component for that case here, yeah, because I want to modify my member, and then I need the member component. I tell my member component it should apply my changes to index number 5 and 7. Yeah, I want to modify member number 5 and member number 7. And then I only apply the changes that I want to have. Yeah. In this case, I plan to extend them with a member hinge on both sides. Yeah. It is not required to define all the other information again. Yeah. The section, the eccentricity, which is assigned to these members. Yeah. It's not required. You only assign what you want to modify or what you want to add. Then you connect the component again with the export component. I think that's clear. And here you make sure to use override, to set override to false. Yeah. Again, if you set it to true, then your structure would be overwritten during the export. That's not ideal. Set that to false, and that's all you need to do. That is starting a modification in RFEM, and I can show that as well. So now it's writing these hinges to the members, as you can see. And the rest is still the same. Yeah, it's still the same member. It has the same section. The eccentricities, everything is untouched. It just added the hinges here. Yeah? That is task 1. Task 2 should be to move the opening parametrically through the slab. Yeah. How can we do that? Well, there are various ways. I want to basically read the coordinates from RFEM into Grasshopper and then modify them. To do so, I use the import component in a similar way as I did it before, yeah, in example 5. Import component, just the nodes, and again, only the 4 nodes from the opening. Yeah? I don't care about the others here, so that's why I'm using a filter. Then I split the data package up into the nodes. I extract the Grasshopper nodes. Yeah, we can see that here. Oh no, I didn't run the import. Just a second. Now I run the import. Okay. So those are the 4 nodes that I just imported. And then I basically modify them. In my case, I move them, yeah, with the MD slider. So I can easily move them around to the expected new location. And then I use again a node component to which I assign again the index numbers of the nodes that I want to modify. Actually, I could have connected that panel like this panel also to this component. I somehow copied it, but it's the same content. And then the Grasshopper node input with the nodes I just copied, yeah, with the move component. So basically, I tell my component the new location of those 4 nodes comes from Grasshopper, yeah, from that component. Then I need to connect that as well to the export. Yeah, it's not connected yet. And can I move it? No. I hope we can see it live. Then it will automatically run. Yeah, it's already done. It will, because I left the export open, basically. Yeah? It started the export directly, and it moved the opening from the left-hand side to the right-hand side. Yeah, it's like a live link now. So whenever I let me do it this way. When I move this now to another location again, then we should see it moving to the new location. Yeah. So you can modify an active structure via Grasshopper. And the key is to set the override to false and assign the index numbers of the objects that you want to manipulate. That's all. Yeah. Okay, that was the last sample file for today. As a little recap, I wanted to show to those who haven't seen it before or those who are interested, I wanted to show the capabilities of our Grasshopper plugin. You were able to see that we can export model data, load related data, the loading as well. We can run calculations, export results, import them again. In general, we have an import from RFEM into Grasshopper. So I think the main tasks or the main components are included, so you can cover your structural your analytical models that you do on a daily basis. And yeah, and that's what I wanted to show today. And we also, as I said, hand these files out. You can download them from the webinar page, so you can use them as a little help file, as a guideline when you start your own project. With that being said, I thank you for the interest in the webinar and the topic. Thank you for your time, and I hand it back to Andreas.
Thank you, Lukas, for your nice presentation. I have an additional hint for you. We have released our new online courses. You can find them under support on our website and training. Then the online courses are here. We provide them in German and in English. And if you click on English, then you can see the different online courses to RFEM 6, Eurocode 2, or Eurocode 3. You can purchase such a course, and the different parts of the course can you watch whenever you have time. You can have a break at any time as you want and you have time. Okay, that should be also all from my side. I thank you for your attention. Thanks to Lukas for your presentation. Thanks to Paul for answering the questions. I wish all a nice rest of the day. Bye-bye.